Hi everyone, welcome back to ASFC Physics. What we're going to be looking at today are the multiple choice questions from the OCR Physics A Exploring Physics paper from June 2017. As always, by far the best way of attempting these questions is, well, to attempt them independently first and then only afterwards check with my solutions. Additionally, if you're using this as a revision resource, the best thing to do would be just to pause this video, attempt the question, and afterwards check with my solution. Okay, well, let's get started. Question 1. The diagram shows below the motion of positive and negative particles in a conducting solution. Which statement is correct? A. The current in the solution is 0. Well, that's not the case. The reason why this is not true is because currents do not cancel each other out the way vectors would. We have some charge going to the left and some charge going to the right. If we were to attach an ammeter between those 2 points, there's definitely going to be some current. B. The conventional current is to the left. Yep, this is absolutely correct. The reason for that is because conventional current is always indicated by the direction of movement of positive charge. So in this way, in this question, the positive charge is moving to the left. So this has got to be correct. Just for completeness, let's just go through the rest and see why they're wrong. The positive particles are always protons. Well, that's not true. They could be ions. The negative particles are always electrons. That's not true. They could be negative ions as well. Okay, so for question 1, the correct answer is B. Let's go through the second one. We have 1,000,000 electrons travel between 2 points in a circuit. The total energy gained by the electrons is 1.6 times 10 to the power of minus 10. What is the potential difference between the 2 points? Okay, well, let's calculate the energy per electron. So because the total energy is 1.6 times 10 to the power of minus 10. However, there's 1,000,000 electrons. So in order to find the energy per electron, let's call it W, we're going to need to divide that by 10 to the power of 6. A useful rule of thumb to remember is that a million is actually equal to 10 to the 6. So if somebody is a millionaire, well, they really are 10 to the 6 air. Okay, so 1.6 times 10 to the power of minus 10 divided by 10 to the power of minus 6. So this is going to give us 1.6 times 10 to the power of minus 16 joules per electron. So this number here was for 1,000,000 electrons divided by 10 to the 6, and that's your number for just one electron. Then we're going to use one of my favorite equations in physics, that the potential difference is equal to the energy per electron per unit charge. So this is going to be equal to W divided by Q. We know that our W in this case, our energy per electron, is 1.6 times 10 to the power of minus 16. And we know that our charge of an electron is 1.6 times 10 to the power of minus 19. And we'll probably not even need a calculator for this one. We can just cancel those 1.6's, and all we have is 10 to the power of minus 16 divided by 10 to the power of minus 19, which is going to equal 1,000, or 1.0 times 10 to the 3 volts of potential difference. So this means the correct answer in this case is going to be C. Okay, question 3, which is not a unit of energy. Just scanning through these, you can immediately see that we also have the watt there, and we know that watt is the unit of power. So D is definitely not the correct answer. Just to go through all of these, so kilowatt hour, definitely a unit of energy, and this is because energy is power times time. So if you give your power in kilowatts and if you give your time in hours, what you get for the energy is the amount of energy to be in kilowatt hours. The EV, that's also unit of energy. This comes from this equation. So V is W over Q, where W is the energy. So W is V times Q. If you set your charge to be the electron charge, so this W turns into EV. So this is where this comes from. Joule, we know that's the SI unit of energy. So what is the unit of power? Okay, question 4. A circuit is shown below. The battery has negligible internal resistance. Excellent, we don't have to worry about internal resistance. The temperature of the NTC thermistor is decreased. Before I even read the rest of the question, I'm just going to draw this sketch this little graph of resistance against temperature for a thermistor. Now we should know this shape for the exam. It looks something like this. Now in this case the temperature is decreasing, so that means that the resistance is increasing. So as the temperature goes down, that means that let's not draw too many arrows. That means that R increases. Perfect. Which of the following statements is or are correct? Okay, let's go through all of them. The current at X increases. Okay, well, let's have a think about what's happening to the resistance as a whole in the circuit. Because the temperature is decreasing, the resistance of the thermistor is increasing, which means that the total resistance increases. The total resistance in the circuit will be increasing. Now, because of that, remember I is equal to V over R. If the resistance increases, that means that the current will have to decrease. Okay, so we know that the first one is not correct. Second one, the current at Y remains the same. Well, we know that the resistance of the surrounding resistors will not change. So that means that this has got to be correct. 3, the potential difference across the thermistor increases. Okay, well, let's have a think about this. We know that the current will decrease. And let's have a look at the voltage across this fixed resistor. This is equal to IR. R is fixed for this resistor. So that means that if the current is decreasing, the voltage across this has got to decrease as well. However, if the voltage across this fixed resistor decreases, that means the voltage across the thermistor has got to increase. So 3 is also correct. So in this case, the correct answer is going to be B, only 2 and 3. Guys, questions 5 and 6. A progressive wave of amplitude A has intensity I. Okay, before even reading the rest of the question, I'm just going to write that intensity is proportional to the amplitude squared. I'm just going to give a name to that or symbol to that constant proportionality. Let's just call it K. The wave combines with another wave of amplitude 0.6 at a point in space. The phase difference between the waves is 180 degrees. What is the resultant intensity of the combined waves in terms of I? Okay, well, the first thing to notice is that because the phase difference between the waves is 180 degrees, this means that we're dealing with destructive interference. This means that a peak is going to meet a trough, which means that the resultant intensity is going to be A minus 0.6 A, which is going to give us 0.4 A. Okay, so let's say that the total intensity, I total, let's call it, is going to be K multiplied by 0.4A, and then all of that we're going to square, like so. Okay, well, let's find our constant of proportionality just from our first expression, just for the first intensity I, so K is going to be I over a squared. Now the way we always solve these questions is by getting our constant of proportionality k and finding an expression for it, which we have, then just subbing it back into the equation. Okay, so let's do that. That means that the total intensity is going to equal. Now, rather than k, I'm going to write a over a squared times 0.4 squared times a squared. So all I've done really is I've just squared everything inside of the brackets. Okay, now we can do our favorite thing in physics, which is to cancel and simplify expressions. So let's get rid of these a squared. And we have an expression for the total intensity in terms of I. So in this case, I total is simply I times 0.4 squared, which is 0.16, which leads us to a correct answer being A. Okay, so let's have a look at the next one. Stationary waves are produced in a tube closed at one end and open at the other end. The fundamental frequency is 120 Hz. What is a possible frequency of a harmonic for this tube? Okay, now the first thing to note is that whenever we have a closed tube on one end and an open end on the other end, we have some boundary conditions. We're always going to have a node on the closed end. We're always going to need to have an antinode on the open end. This is our fundamental frequency node leading directly to an antinode. We cannot have a factor of 2 of that frequency because what we're going to get, or a factor of a half, in fact any even factor multiplying it, because what we're going to get is a node, then an antinode in the middle, then a node right at the end. Now this is not allowed. The reason for that is because we're just going to have an antinode right at the opening of the musical instrument, which kind of defeats the purpose of having a musical instrument to begin with. So what we are allowed are odd multiples. So if we have an odd multiple, let's say 3 times the length or 3 times the frequency or a third of the frequency, we're going to get a node on one end, then an antinode, then a node, and then another antinode towards the end of the tube. So odd multiples are fine. If our fundamental frequency is 120 Hertz, 60, that's a factor of a half, so that's even, so it's not going to be this one. 240, that's a factor of 2, that's an even factor, so that's not going to be this one. 360, aha, bingo, that's the one, so that's a factor of 3. So the correct answer is C. 480 Hertz is also a factor of 4, so that's not going to be it because it's an even factor. Okay folks, hopefully this one makes sense. Questions 7 and 8. Starting with question 7, the graph below shows the variation of potential difference V with charge Q for a capacitor. Which row is correct for the gradient of the graph and the area under the graph? Okay, well, let's get started with some of the equations of this topic. So we know that Q, the charge, is equal to C times V. In order to perform y equals mx plus c analysis, what we need to do is rearrange for whatever is on the y-axis. In this case, this is v. So just rearranging for v, we get that v is equal to q over c. Another way of writing this is that v is equal to 1 over c multiplied by q plus 0. So we know that y equals mx plus c, v is on the y-axis, q is on the x-axis, which leads our gradient to be 1 over c, which is capacitance to a power of -1. So just from that little calculation in itself, we know that the answer is going to be either A or B. Now let's have a look for the area under the graph. Now, we know that work done, or energy, or electrical energy, which is also equal to work done, is equal to V times Q. Now, in order to calculate the area underneath the graph, we need to multiply those two quantities, and in fact we know that the area underneath a V and Q graph is equal to the energy and the work done, which leads us to the correct answer being A. Okay, question 8. A capacitor discharges through a resistor. Time t is equal to 0. The charge stored by the capacitor is 600 microcoulombs. The capacitor loses 5% of its charge every second. What is the charge left on the capacitor at a time t is equal to 4 seconds? Okay, well, we can do this a number of different ways. We can use the exponential formula. However, this is going to be quite time consuming. Probably by far the best way of tackling this question is if we just know the compound interest formula really, but we can calculate the charge left on the capacitor just simply using our initial amount, 600, multiplied by 1 minus our the amount that we're losing, which is 5%, which is 0.05. Let's just write this a little bit more clearly. So 1 minus 0.05, and we need to raise that to the number of times that we're doing this. So we're doing this 4 times over 4 seconds. And if we put this into a calculator, I'm going to get 488.7. Let's round it up to 489 microcoulombs, which leads to the correct answer being D. Now, if you can't remember the compound interest formula, by far the next easiest way of tackling this question is just to do this manually. So you can quickly calculate 5% of 600, take that amount, then calculate 5% of that, take away that amount, and repeat this 4 times until you reach 489 microcoulombs. Okay folks, let's have a look at the next one. We've got two parallel plate capacitors have an equal and opposite charge. The separation between the plates is doubled, so shall I just write over here on the side? So we increase the distance between them by a factor of 2. The charge on each plate remains the same, but the potential difference between the plates doubles. Okay, so because Q is equal to C times V, if we were to double the voltage, the only way we could keep the charge the same would be to halve the capacitance. Okay, which statement is correct? The capacitance of the capacitor doubles. We've just shown that this is not correct. It will actually halve. So should we just cross this one out as it's not correct? B, the energy stored by the capacitor is halved. Well, the energy of a capacitor is given by the formula half CV squared. So in this case, the capacitance is halved, so this will decrease by a factor of a half. So let's write this over here. So this decreases by a half, but additionally it will also increase because the voltage has been doubled. This effect is due to the decrease of the capacitance. However, we need to factor in the increase. So it will increase by a factor of 4 because the voltage is doubled, and then this is squared on top of that. So overall, the energy will increase by a factor of 2, which is a half times 4, will increase by 2. So B is not going to be correct as well. C, the permittivity of free space doubles. Well, we know that that will never happen because the permittivity of free space is actually a constant. D, the electric field strength between the plates remain the same. Well, by the process of elimination, this has got to be correct. And additionally, we can show this by simply just using the formula E is equal to V over D. So we know that this will increase by 2, and this here will also increase by 2. So overall, it will remain the same. So the correct statement is D. Question 10. Which statement is correct? Hadrons are made up of protons and neutrons. So this is incorrect. Hadrons are particles which are made up of 2 or more quarks which are held together by the strong nuclear force. B, a positron or a proton are examples of leptons. Well, that is not the case. A positron is an example of a lepton, but a proton is not. A proton is a hadron. C, the positron and electron have the same mass. Yep, that is correct. Remember, particles and their antiparticles, they have the same mass, but they have opposite charge. And D, the weak nuclear force is responsible for alpha decay. This is incorrect. The weak nuclear force is responsible for beta decay. So in this case, the correct answer is C. Let's move on to the next few questions. Question 11. An electron moves in a circle of radius 2 centimeters in a magnetic field of flux density 170 milliteslas. What is the momentum of this electron? So anytime we have an electron which is moving in a circle in a magnetic field, we can set the magnetic force, QVB, equal to the centripetal force, which is mv squared over r. We can immediately do some cancellations, so let's cancel those v's, and what we get is that QB is going to equal mv over r. Now we're looking for the momentum of this electron, so rather than finding the speed and then multiplying it by the mass, we notice because momentum is equal to mv, that we can just rearrange for m times v. So let's do that. So mv is going to equal qbr, and the momentum mv is going to equal q, which is our charge of the electron, which is 1.6 times 10 to the power of minus 19. Now we're going to have to be quite careful with the units. The magnetic flux density is 170 milliteslas. Remember, milli is 10 to the power of minus 3, so 170 times 10 to the power of minus 3. And R is given in non-standard units, so that's 2 centimeters. So I'm going to times that by 2.0 times 10 to the power of minus 2. And I'm going to carefully put all of this into a scientific calculator, which is going to give us 5.44 times 10 to the power of minus 22 kg ms to the power of minus 1, which leads us to the correct answer being D. Notice how they've given the same answer over here, but this will be the answer without the unit conversion. So we just have to be quite careful that we choose the correct one. Okay, well, 12. A particle collides with a stationary oxygen 18 nucleus. The collision produces fluorine 18 and a particle X. What is particle X? Okay, well, we need to conserve both the atomic number and the atomic mass at the top. In other words, we need to conserve the proton number and the total nucleon number. So over here on the left, we can see that in total we have 19 nucleons. So particle X is going to have 1 nucleon. Because the top numbers have got to add up. We've got 19 on the left and we've only got 18 initially on the right, so we're going to need one more. And let's have a look at the proton number. So we have 9 on the right and we have 9 on the left. So the proton number is totally balanced, so this is going to be 0. So which particle has 0 protons but 1 nucleon? This has got to be a neutron. Remember, so for any particle, the number here is your protons plus neutrons, and at the bottom here we just have our proton number. Okay, question. So the correct answer is, oops, a neutron. Question 13. A beam of charged particles is not deflected when it passes through a region where there's both magnetic and electric fields present. In other words, let's say this is our beam of particles and it passes through some region in which we have an electric field and a magnetic field. Which statement is not correct? All the particles have the same speed. Yet this should be correct, because otherwise the particles will be overtaking each other, and we also might get some distortions in the actual beam, which we are not observing. The resultant force on each particle is 0. This is true because if it wasn't 0, there will be some deflection when the beam of particles is entering the electric and magnetic fields. C, the magnetic force is equal to the electric force on each particle. Chances are in this case we're probably dealing with something like neutrons or something electrically neutral. So in this case the magnetic force will be equal to the electric force, and it will probably be 0. So this is also correct. The magnetic field and electric field are in the same direction. Nope, this is never the case. They're always perpendicular to each other. So in this case, the correct answer is D. 2 questions. So question 14, there are 4 important attenuation mechanisms by which X-ray photons may interact when they pass through matter. Which mechanism is the X-ray photon scattered with a longer wavelength? Now, if we revise this topic, we should pretty much instantly know that this is the Compton effect. So this is a recall question. So the correct answer in this case is B. Now, rather than just give out the answer, let's just quickly revise what the Compton effect really is. So let's do a quick drawing. So let's say that we have our electron over here. As you can see, it's negative. So this over here is our electron. And what we would do is we would target our electron with some light. Normally in the case, this could be some photons, and let's focus on one of them in particular. So this is our incident photon just over here, and let me just label that. So this is the incident photon. In this case, the incident photon has quite a lot of energy, a lot more than the work function. So what happens is that this electron gets scattered. So the electron is scattered like so. However, the incident photon still has some energy left. So it is also scattered. So scattered photon. The reason why I'm drawing this in red is because red has a longer wavelength because it has less energy. So there's still some energy left, and this one here has lower energy. Essentially, this is the excess energy which has been left after the electron has been scattered, and hence it has a longer wavelength. The reason why, if it has lower energy, it has a longer wavelength is because they're inversely proportional to each other. This is given by the E is equal to hc over lambda. In other words, if the energy is low, the wavelength is quite big. Okay, so hopefully that was a good little revision of the Compton effect. Right, question 15, the very last question. A ray of monochromatic light is incident at the boundary between 2 transparent materials of refractive index N1 and N2. The critical angle theta is equal to 80 degrees. Okay, perfect. So what we get here is actually total internal reflection. We have an incident ray which goes along here, and then it's trapped along the boundary. So let's see if I can draw this. So this is in fact the path of our ray. Now something to watch out for is that the ray is going from N2 to N1. So this could be a little bit of a source of confusion, that our first medium is actually been named in this question N1. 2. So it's definitely something to watch out for. Okay, well, in this case, we're going to have to use Snell's law, which is that n sine theta is equal to a constant. In other words, our n times our first angle is going to equal our second n times our second angle. Okay, so we start off with n2. So n2 times the critical angle, which is equal to 80 degrees, times sine of 80 is going to equal our second medium, which is n1. And notice that as the ray is trapped along here, our angle to the normal is actually 90 degrees. So anytime we have total internal reflection in which the ray is trapped at the boundary, our angle of refraction is actually equal to sine of 90, which is just equal to 1. Okay, so we're looking for the ratio n1 over n2. So all we need to do is just rearrange for n1 over n2. So n2 times sine of 80 is just going to equal n1 because sine of 90 is 1. So n1 over n2 is just going to equal sine of 80. And if we put that into a calculator, this is going to equal 0.984. Let's round that up to 0.98. So the correct answer is B. Okay, folks, so hopefully you've enjoyed looking through those solutions. If there are any questions, feel free to drop me a line with a comment down below, and please consider subscribing.